Hi guys, welcome back to my YouTube channel, Let's Crack Real Math. My name is Viraaj, and in this video we'll be having a look at a lot of examples on the topic circular measure. So before I begin, I would strongly advise you guys to go over my previous video on circular measure, which covers it in both degrees and radians, as all the ground foundations of that topic will be used in this particular video. And we will only be going through examples and a lot more of tougher questions on circular measure. So without any other delay, let's begin. So in this video we'll be solving circular measure in radians mode, not in degrees. However, my video on circular measure was in both degrees and radians, so if you want to know how to do it in degrees, you can quickly jump over to that video and that will really explain it. So let's go right into our first example. Okay, so the first example says, in figure 0.1, okay, let's zoom in a bit. In figure 0.1, OAB, okay, OAB is a sector of a circle with center O and radius R. Okay, good to know. AX, that's AX here, is a tangent at A to the arc AB, okay, and angle BAX is equal to alpha, or A. Let's say alpha since there's already A over here. So we now need to show that angle AOB is equal to 2 alpha. This is 2 marks and we need to show it. Okay, so let's have a look at the diagram again. Now we can see that there is a right angle over here. That means it's 90 degrees somewhere over there, right? And we know that from here to here, as it's shown, is alpha. So from, let me use another color. So from here to here would always obviously be 90 minus alpha. So that is BAO, angle BAO is equal to 90 minus alpha. BAO, that means angle where there's A and A's over here. So that angle over there, of the triangle obviously, is 90 minus alpha. Now if this is 90 minus alpha, this over here should also be 90 minus alpha. Now why would this be 90 minus alpha? Because this is, if you look closely, an isosceles triangle. You can see the length of this is R and the length of this is R. And when you have the same lengths over here, then it's an isosceles triangle, meaning the bottom angles over here and over here are always the same. So if BAO is 90 minus alpha, that means ABO, angle ABO, is also 90 minus alpha. And if both of them are 90 minus alpha and we want to find AOB, we know that all of this adds up to 180 degrees in a triangle. So that means our angle AOB is equal to 180, sorry, a second, 180 minus, and then in brackets we can have 90 minus alpha plus 90 minus alpha. Because we have our two angles over here, that's over here and over here, to be 90 minus alpha, and to get this we have to subtract both of them from 180 because all the angles in a triangle add up to 180. Now simply using your algebra doing this, we know this is 180 minus brackets 90 plus 90, that's 180, and minus alpha is minus 2 alpha, and then if you expand this is 180 minus 180, because this minus would now come here, plus 2 alpha, because the minus and minus over here will combine to give a plus. This cancels this, you are left with 2 alpha, and that is exactly what they asked us to prove. Yep, to show that this is 2 alpha. On to the next part. It says find the area of the shaded segment in terms of R and alpha. So we need to find the area in terms of R and alpha. So our final answer won't be an integer or an exact value, it will be in terms of R and A. Now if I just get rid of all this over here just to get a clearer picture, we need to find the area of this shaded segment. Now we know the whole of this is a sector. And we know that from somewhere here to here we have a small triangle inside. So if we do the area of the whole sector minus area of this triangle over here, then we will eventually be left with the shaded region, and that is exactly what we want. So to go about this, we would write first off, say area of shaded area of shaded region is equal to the area of sector minus the area of the triangle. So we know that our formula for area of sector is half r squared theta, and our area of triangle, in general terms, it is half base times height, but we do not have that sort of information over here. We can't really tell which one is the height and which one is the base. So we will use the formula half AB sine C. And in this case, our A and our B are both the same. That's R. So simply half R squared sine C minus half R squared sine theta. C is simply the angle that we're taking. And the angle that we are considering, obviously, is this angle over here, which we eventually know as 2 alpha. So all we have to do is just simply take that and substitute it in place of theta over here and over here. So what we'll now have is something like equals to half r squared into 2 alpha minus half r squared sine alpha. Oops, sorry. Sine alpha. Yeah. You can leave your answer like this. It should be marked, or if you want to go the extra step, you can just factorize this. You can factorize the half r squared out, so you would have half r squared into 2 alpha minus sine alpha. Either of these two are correct. And that is the answer for that question. Just 2 marks, both these, total 4 marks, but you can see that it is a bit technical. Right, on to the next example. This one says, it's just smaller. Okay, this one says the diagram shows a circle with radius r cm and center O. Okay, the line PT, okay, is the tangent to the circle at P, and angle POT is equal to alpha radians. Okay, good to know. The line OT meets the circle at Q. Okay, yep, figured it out. The first part says express the perimeter of the shaded region PQT in terms of R and alpha, or R and A, but let's say alpha. Express the perimeter of the shaded region PQT in terms of R and alpha. Now they want us to find the perimeter. That's the first thing. So simply we need to find P to T. We need to find the length of that. We need to find the length of Q to T. And we also need to find the length of this little arc over here in order to get the full perimeter of the shaded region PQT. And it's said in terms of R and alpha, so we want to exactly have certain values. Now for the arc length over here, we know the formula for arc length is r theta, and in this case our theta is alpha. So for starters, we know that we will have r alpha as one of the answers, but we need to find the rest as well. So r alpha plus what? Now in order to get PT, we can use trigonometry. If you are not comfortable with trigonometry, you can go in my previous video on trigonometry of right angle triangles in this case. since there is a 90° over here. Now to find PT, we can simply use secant, and we can use the TOA. That's tan alpha equals to TOA, that's O over A, that's our opposite, which in this case is PT, over our adjacent, which in this case is R. Of course, alpha is the angle over here, that's tan theta is equal to PT over R, so tan A is equal to PT over R, and if you cross multiply, you know that your PT is equal to R tan alpha. And if you remember, PT is this length from here to here, and that is what we also need as part of a perimeter. So RA, or R alpha, plus R tan alpha, plus we need one more, and that is the length of Q to T. Just erase this so it becomes clear. We need Q to T, we need this length. Now in order to find this length, we can again use trigonometry to find the whole of it. We can find O all the way to T, and then whatever we get from that, we can subtract R, because you know, if from here to here is R, then from here to here, if O to P is R, then O to Q is also R. So if we find the whole of OT, we can subtract R from that, and then we can get our QT. So in order to get our OT, again, we use secant, this time we use we use cos. Cos alpha is equal to adjacent over hypotenuse. Adjacent in this case is your R over the hypotenuse, which in this case is OT. That's the full length. And if you make OT subject to the formula, you know OT is equal to R over cos alpha. But this is OT, that's the whole, and we don't want the whole, we just want Q to T. In order to get Q to T, you simply subtract R from R over cos alpha. So this is, so basically our QT rather, QT is equal to R over cos alpha minus R. Now if you want, you can leave your answer like this for this particular part, or you can get them under a common denominator, so you can just simplify this so you have something like R minus R cos alpha over cos alpha. What I simply did was I just times this by cos alpha. You know this is over 1, so yeah. So you can take this back up to part of our answer right over here. So we have R alpha plus R tan alpha plus R minus R cos alpha all over cos alpha. And that is the final answer for that part. Again, it said express it in terms of R and alpha, sorry, and that is what we have precisely done. Okay, next part says says in the case where alpha is 1 over 3 pi and R is 10, okay, good to know, find the area of the shaded region correct to 2 significant figures. First things first, since our alpha is in 1 over 3 pi, whenever your angle is in pi, we always use radian mode in your calculator. To get to radian mode, you simply do shift and mode, and then you press 4, or whichever number represents RAD, that is radians. So you want to go into radians mode first. Now it says find the area of the shaded region. So again, if I clear this up again, it says find the area of the shaded region. We know that the whole of this is a triangle, a right angle triangle, and if we subtract the area of this sector from that triangle, we will be left with our shaded region over here. So in this case, the formula that we will be using is simply area of shaded region. Shaded is equal to the area of the triangle, minus area of sector. To get our area of triangle, we can use half times height times base, or height times base divided by 2, same thing, minus area of sector, that's half r squared theta. This is half times our height, which if we look at it from this angle, our height that's from here to here is r, so our height is r, times our base, which in this case is p to t, and we found out that our p to t is r tan alpha, so we can just simply put that in, times r tan alpha minus the area of sector, that's half r squared alpha. And they gave us the values of r and alpha respectively, so just input those values in and solve. So we have half times r, which they said was 10, times r tan alpha, that's 10 tan 1 over 3 pi, minus half into 10 squared into 1 over 3 pi. And simply just put this in your calculator, make sure you input all your values correctly, no silly mistakes, and doing that should give you 34.24, but the question specified two significant figures, so you do 34. And it doesn't hurt to put your units down, and since the radius was in centimeters, we can say that the area was cm squared, or you can leave it as units squared, whichever one. Since it is area, we will need to have something squared, and that is the answer for that question. On to the next example. Sorry. Okay. This one says, in the diagram OCA and OBD are radii. Radii is the plural of radius, so there are two radiuses or radii we're working with here. Are radii of a circle with center O and radius 2r cm. Okay, good to know. Angle AOB is alpha radians, equal to alpha radians. CD and AB, so we have two arcs. We have a C to D arc and we have an A to B arc, which is of the same circle since they have this common center of O and a common angle of alpha. CD and AB are arcs of circles with center O and radii r cm and 2r cm respectively. The perimeter of the shaded region is ABDC is 4.4 r cm. Part I asks us to find the value of alpha. Okay, they told us that the perimeter of the shaded region, that's this arc length over here, this arc length over here, A to B, C to D, and from D to B, and from C to A, all of this, adding up all of that, should give us 4.4 r. If this over here, if C to A is r, then we know that D to B is also r. So all we have to now have to do is find these arc lengths of A to B and of C to D, add them all up and equate it to 4.4 r. So we have something like r plus arc length of the smaller arc length, that's CD, is simply r alpha plus r alpha, because the arc length formulas are theta and our theta is alpha in this case, plus our arc length of A to B, which in this case would be 2 r alpha. Now why 2r alpha? Because the question did state that it's of radius 2r cm. If from O to C is r, and from C to A is also r, then from O to A is 2r. So that's common sense. All of this is equal to 4.4r. Now we can solve this using algebra. R plus r is 2r. R alpha plus 2r alpha is equal to 3r alpha is equal to 4.4r. Take this guy to the other side, we'll have 3r alpha equals to 4.4r minus 2r, which is 2.4r, and then alpha is 2.4r over 3r. This cancels this, and 2.4 over 3 is 0.8. So alpha is 0.8 radians. And that's the answer for that first part, because they asked us to find the value of alpha. On to the next part. It says it is given that the area of the shaded region is 30 cm squared. Find the value of r. They're saying that the area of the shaded region, so the area of the shaded region is 30 cm squared. Now if we can see, all of this is a huge sector. We have one big sector, that's sector OAB, and then we have a smaller sector, that's OCD or ODC. And if we take the area of the bigger sector and minus it and subtract from it the area of this sector over here, we will be left with our shaded region over here, and that is exactly what we're going to do. So simply we will now solve this like this. We will have our shaded area is equal to our bigger sector, the area, obviously, I'm not going to write it, it's too much work, bigger sector area minus the smaller sector area. The shaded area they said was 30, so we have 30 over here. Of course, our formula, we use the same formula, half r squared theta minus half r squared theta. 30 is equal to half into 2r, because the radius of the bigger sector is 2r, because r plus r is 2r, and then you square of that according to the formula, and you times this by 0.8 or alpha basically, because that is our theta, minus half of r squared, simply r into 0.8. Simplifying or expanding this first, really, you would get half into 4r squared, because 2r times 2r is 4r squared, into 0.8 minus half r squared 0.8. Using your calculator and simplifying all this, you get 30 is equal to 1.6 r squared. That's because half times 4 is 2, and if you times 2 by 0.8 you get 1.6, so 1.6 r squared minus half times 0.8, that's 0.4 minus 0.4 r squared. That is 30 is equal to 1.2 r squared. If we're solving for r, we do r squared is equal to 30 divided by 1.2, and 30 by 1.2 is 25, and r is simply the square root of 25, which is r is plus minus 25. In this case, r can only be positive 25, because you cannot have length or radius to be in minus. And that is the answer to that question. On to the final example for this video, and this is a challenge question. Challenge question. So do pause the video and have a go at this by yourself, and then resume the video to see if you're correct or incorrect. If you are incorrect, please take note of the mistake. Wow, 7 marks, so it's going to take some working this. Right, it says the diagram shows triangle ABC where AB is equal to 5 cm, okay, AC is equal to 4 cm, and BC is equal to 3 cm. Okay, good to know. 3 circles with centers at A, B, C have radii 3 cm, 2 cm, and 1 cm respectively. The circles touch each other at points E, F, G, lying on AB, AC, and BC respectively. Find the area of the shaded region EFG. That's a lot of words and numbers. It's alright, let's take time, let's understand it, let's bisect this question. It's no crime to take time and understand it first. So we have A to B to be 5 cm, 3 plus 2 is 5. We have AC, A to C is 4 cm, 3 plus 1 is 4. And we have B to C to be 3 cm, 2 plus 1 is 3, yeah. And then they all have their individual radius or radii. This small sector over here, this sector over here, has a radius of 1, as you can see. If I use another color real quick, yellow. If I look at this sector over here, this one has a radius of 2. And if I look at this sector over here, this one has a radius of 3. Now they asked us to find the area of the shaded region, and we know the area. If I just look at this and we all look at this, we know that all of A, B, C is a triangle, and in order to get the area of this triangle we need to subtract the area of these individual sectors inside it to get this shaded region over here. Well, in order to get this we need to have specific values such as your angles over here in order to get the area of the sectors. So let's see how we can go about this. Now this information may be hidden, but you have to eventually find out and think outside of the box. But this is a right angle triangle inside. Now how do I know it's a right angle triangle? They never stated it's a right angle triangle, they never said it's a right angle, but it is right angle triangle. Look at this. We have this triangle over here. If you simply tilt this, let's just tilt this to something like this, right? Let's say tilt it to being something like this. We just tilted it somehow, right? So this becomes our C over here, this becomes our B, and this becomes our A. So we slightly tilted it to the right. We can see that from A to C, like over here, A to C is 3 plus 1, 4. Our C to B is 2 plus 1, that's 3. And our A to B, that's 3 plus 2 is 5. And we know, using Pythagoras, 4 squared plus 3 squared is equal to C squared. 4 squared is 16, plus 3 squared is 9, 16 plus 9 is 25, is equal to C squared, so 25 equals to C squared, and our C is equal to square root of 25, which is 5. And that is the case over here. Hence, there is a right angle at angle ACB. So angle ACB is a right angle. So simply, somewhere here, we have our right angle. And in terms of radians, our right angle is simply half of pi. So we can start with that as our information, that angle ACB is equal to half of pi. Now on to the next angles. To find angle ABC, simply this angle over here, because you know, after drawing it like this, it makes it very easy to help and solve trigonometry as well. To find angle ABC, we can simply use trigonometry, and we can use the sine rule. So sine theta, because that's what we're trying to find, this is our theta over here, equals to opposite over hypotenuse. Our opposite is 4, and our hypotenuse is 5, and our theta is equal to sine inverse of 4 over 5. Make sure your calculator is in radians, and doing this, our theta is roughly 0.927. You can leave it at that. So angle ABC is equal to 0.927 rads. So for the final angle, that's this angle over here, angle BAC. We know that all the angles in a triangle add up to 180 degrees, that they equal to pi. 180 degrees is pi in radians. So angle BAC simply equals to pi minus both of this, so pi minus 1 over 2 pi minus 0.927, and doing this, angle BAC is roughly around 0.643, again rads. So now that we have our respective angles of all of them, now we can proceed with the general overview of that, the shaded area is equal to the area of the triangle minus the area of all of the sectors combined. Area of sectors, not just one sector, all of the sectors. So area of triangle, we can use half base times height since we have a right angle as we saw over here. So our height is 4 and our base is 3, so half times 4 times 3. Half times 4 times 3 minus the area of the sectors. Now this might take a bit of a while, but we'll do it. We know the formula of area of sectors is simply half r squared theta. So let's simply go by it one by one. Let's look at the first sector. Let's look at the yellow one over here. So our r is 2 and our theta for that one, that's angle ABC, is 0.927. So we have half into 2 squared into 0.927 plus, now let's look at our let me just put this in brackets as well, helps to differentiate, plus our next sector. Let's look at the blue one. The radius is 3 and the angle, that's angle BAC, that's 0.643. So plus half into 3 squared into 0.643. Close this, plus the next sector, that's the final sector. The radius is 1, I believe. Yep, 1. And it's a right angle, so your theta over there is simply 1 over 2 pi plus half into 1 squared into 1 over 2 pi. And that is how you go about this. Half times 4 times 3, that's 12, divided by 2, that's 6, so 6 minus, if you do all of this separately and input this into a calculator, you get 6 minus 1.854 plus 2.8935 plus 1 over 4 pi. Make sure you input all this correctly into a calculator. Make sure to double check it as well, because any sort of small mistake can literally alter the whole answer. Simplifying this further, you have 6 minus 5.53 and final answer is 0.47. Obviously this was all approximated. Whenever you're working with it, look at your question, and if they specify to what approximation you want to, in this case it wasn't really specified, so I just went with 2 SF as my final answer. Yep, final answer is 0.47 cm squared, or you can use units squared since it is asking for the area of the shaded region. And that is the answer to that question. As you can see, it was slightly complicated at first, really just to understand it, but it's always great to take your time and, if possible, re-illustrate the whole thing. It helps you understand the bigger picture. And that indeed brings us to the end of this video. Thank you for watching. Hopefully you enjoy it. Please do not forget to perform an LSS, that is like, share and subscribe. Thank you for watching. Have a nice one, guys.